Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. I'm also the founder of ServerPod, so if you want to build your backend in Dart, make sure to check that out too. This talk is by Cagatay Ulusoy. Cagatay is working as a Flutter competence lead at Volt and is Google developer expert in Flutter and Dart. He will be talking about reactive navigation management. Let's go!
Hello everyone. You probably already know Dash on left. It is Flutter and Dart's mascot. And on the right, we have Yuho. It is Volt's mascot. And here I am, Cagatay, Flutter competence lead at Volt, also Google developer expert for Flutter and Dart. At Volt, we are building a platform for the delivery of almost everything. We are active in 500 cities and also in 27 countries. We have more than 36 million registered users. At Volt, we bet on Flutter. It is in the most critical part of our operations, and we have an ambitious goal to make the best merchant app in the world, used by 140,000 Volt merchant partners. Let's look at our agenda today. We will start with the problem description. Then we will focus on the fundamentals. And finally, we will go into details with the Coffee Maker demo app. Today, we also announce the new version of Volt Model Sheet. It has some new cool features, but most importantly, it has the demo app source code available in the repository. We will go through the demo app at the end of this presentation. The Flutter Full Stack conference team organized a coaching session for the speakers. Thank you, Victor. And in this session, we were told that frustration is sometimes good because it drives actions. And don't be afraid to frustrate the audience. I hope you don't mind a little bit frustration in the next couple of slides. And here we are. State management, the hottest topic in the Flutter community, like forever, since the first day of Flutter. Have you ever received this question or asked to someone, which state management do you use in your app? I did. Probably you did too. You know Material Mike. Our friend Mike makes a list of state management packages. These packages are ranked based on points, pub likes, popularity, and so on. And here you see the top 30 packages, but there are more. And I was so close to make my own package. I'm happy that I didn't. But anyway, about these packages, people are opinionated and sometimes over defensive and sometimes emotional. But the problem is, many Flutter developers are lost because they feel like they should choose the best among these options when they start their projects and they are stuck. Another top 30 packages from Material Mike. This time it is about app navigation. For a long time, Flutter used imperative navigation, and in 2020, they announced the declarative navigation, also known as Navigator 2. This new way was found very complex for some developers, and we have seen opinionated alternative navigation solutions available in PubDev. These solutions either use imperative navigation or have a simplified version of Navigator 2. But which package to go? Go is not the hint here. Do you need any package? The question is this. But my personal take is that building navigation API is complex due to the nature of cross-platform solutions. So you need to build a navigation API that works in Android, iOS, web, desktop, Raspberry Pi sometimes, right? And some developers understand that, yes, this is very difficult, but Navigator 2, it's not that complex. When you read the source code, follow the tutorials, try it, integrate it to your apps, and happily use it without any packages. And some other devs chose to stick with the same old one, imperative navigation, or use third-party libraries that simplifies the Navigator 2. But enough frustration, we had too much. Let's chill and relax a bit. In this slide, I would like to quote the most famous Turkish poet Nazım Hikmet. The most beautiful sea hasn't been crossed yet. The most beautiful child hasn't grown up yet. Our most beautiful days, the ones we haven't seen yet. And the best state management solution is the one that has not been implemented yet. Okay, why I think this way? Because I have 4 years of Flutter experience, and during this time I tried different solutions. But every new thing I tried was better than the previous one. And we kept delivering with these imperfect solutions. And my message is, it is not a showstopper to use an imperfect state management solution. Keep trying, keep growing, and keep shipping. In the second part, I would like to talk about the fundamentals when approaching to reactive app navigation. Again, what I will present is not the perfect solution, but this is based on my learnings and where I stand today. Our topic is reactive navigation management, but what should we understand from it? It is about handling the navigation in a way that it is reactive, response to the state changes in the application state and operating system intents. And navigation is at the core of our application. In my opinion, a good navigation solution requires a good understanding of app architecture, state management, MVVM, and Navigator too. Now let's start with the app architecture. In our demo app, we use layered architecture. We have data layer. This is where the data logic lives. Data logic means that how the data operation should be handled without the concern of why this should be handled. The keywords in these layers are CRUD, abstraction, and orchestration. Data layer is responsible of create, read, update, and delete operations of data, and abstracting the complexities of underlying data sources. A repository class orchestrates the interactions between the data sources. But what are these data sources? So we might have multiple data sources, more than two. Usually you have two. Cache manages the local data store. It is how data is stored locally in the device. And then you have remote data source. It manages the external data sources such as APIs, web services. Then we have the domain layer. It is the brain of the app. It has business logics defined by product leads or product designers. They give you the specs and you implement in this layer. The business logic is about the why. Why do we need these data operations and what the outcomes of these will be? You may use use case classes to represent a single operation or service classes to group the scenarios under one context. Then we have the entities. They represent the real world business objects. Finally, at the top we have the UI layer. It is about the what the UI should display for the current state and the changes to that state. The famous formula, UI is a function of state. We have the state. It is defined by the logic in the state holders. And we compose the widgets within the build method using the state as an input. And the output is the UI, the display. vModel classes and stateful widgets are the state holders. They create and manage the state. And the efficient state management means that preventing unnecessary rebuilding of the widgets when the state changes. Let's talk about now the MVVM. Model is the structures and behaviors in both domain and data layers. It is the encapsulation of the application backend. Here we apply the business rules, we process the data, and we abstract the complexities of these data operations. The model is injected into the vModels. The vModel has to decouple the UI logic from the business and data logic. It transforms the data from the model into a format that we can easily understand and create the widget tree in the build method. vModel processes the events from the view and translates them to actions. These actions will be performed in the model. It also receives updates from the model and translates them into the state updates that are subscribed by the view. Finally, view captures the user actions and forwards them to vModel. And it also subscribes to vModel state updates and reveals when the state changes. What makes the state management potentially complex is defining what state means and updating the state with UI events, data model updates, or operating system events. Here, until time t1, we see that the app has the state Z. The visible screen here is the purple screen. At time t1, event B happens and our V model changes the up state from Z to X. Then the orange becomes visible. Similarly, time t2, state becomes state Y because event A happens and app shows the yellow screen. And at time t3, event C happens, probably the time when the app is closed. Now, let's go deeper to the screen level state management. Here we have screen A on the top. And the V model for the screen A is created and mounted to the widget tree through the change notifier provider widget. Below that we have widget C and widget B. The widget C subscribes to the state changes from the V model with context watch method of the provider. Now an event happens because the user presses the widget F button. The V model receives this event and sets the new state accordingly. In the next frame, the widget C is rebuilt because it is already subscribed to the state changes. Then as a result, widget E is updated, widget F is replaced with widget Z, widget Y is added. Nothing happens to widget G and its children because widget G is a const widget. Let's now talk about declarative navigation. Here we have a navigation stack. We push and pop routes. It is that simple, right? And Flutter team started with this simplicity. Using the Navigator widget, we push and pop routes and manage the entire app navigation. That's simple. And I'm assuming that the Flutter team is not sadistic. But why would they want to make it more complicated and advanced then? As Flutter started to support web, there was a need for navigation solution not only for mobile apps but for all platforms that has screen. And here we have Navigator 2. It introduces this Router widget and it is the parent of the existing Navigator widget. Router allows you to manage the navigation stack in a declarative way and allows you to customize the almost every step of the navigation. It has this delegation pattern which will come soon. Imperative navigation, push and pop routes. And declarative navigation, define the navigation stack by declaring a list of pages. Navigator 2 adds any field to Navigator widget. This field is the pages field. Navigator takes this page list and transforms every page to a route. It is a familiar pattern to us, right? Because when the widget is mounted to the widget tree, create element method of the widget is called and the element is added to the element tree. Similarly, when needed, Navigator widget creates a route from the page object. And here is an example. We see a list of pages given to Navigator widget. When a color or border type is not selected, we only have the home screen. Let's say the color is selected, the blue color. Then the navigation stack now consists of home screen and on top of that the color details screen. Now we are selecting the border type. Here the visible page is the border type page. And below that we have two other pages and when popped they will be visible. This is the Flutter architecture diagram. I'm pretty sure many of you are familiar with it. At the bottom, we have the embedded layer. Above, we have engine layer. And on top, we have the framework layer. And the Navigator 2 is implemented in the framework layer. The Router widget manages the steps in the app navigation and handles the communication between the engine using its components. Our first flow starts with the user typing the URL in the browser address bar. In this case, the engine adds the new address to the browser history and informs the framework layer with relevant data. The route information provider component of the router widget uses this data and provides a route information object to the router widget. Then the router widget asks the parser component to parse the route information object and return a configuration object. This configuration object is a user-defined data type, and it will be used to represent the app state. After receiving the configuration object, then the router widget calls the router delegate to set the new route path and build a navigator widget accordingly. In the second flow, user presses a button which causes an update to the app navigation state, and as a result, the router widget is marked as dirty. Then the build method of the router delegate is called by the router widget. The navigator widget is returned back to the router. Next, the router widget gets the current configuration from the router delegate and forwards this configuration to the parser. The parser provides a new route information, and finally, engine updates the browser history, and the URL in the browser is updated with the new state. This is Navigator 2 in a nutshell. Looks good to me. Okay, the good news is you don't need to customize the entire flow. If you decide to support web, you just have to add more code. And in this example, you see user updates the address bar, the UI is updated. Similarly, user interacts with the UI and the URL address bar is updated. If you target only mobile platforms, it is simple. Only focus on the communication between router and the router delegate. After the fundamentals, let's now see the action. Remember, the source code is available in Vault Model Sheet repository. The app navigation is slightly complex, but not too much. We start with the login page. Once the user is logged in, if the user has not seen the tutorial, we show the home page, and on top of that, we have this onboarding model. Otherwise, we only show the home page, which has a button navigation for each coffee making step: grind, add water, and ready. When the add water card is pressed, we enter to the add water screen, and once the water is added, we navigate the app to the orders page with the ready tab. We also have a navigation driver, and pressing each destination in this drawer takes us to a new route. You can log out, go to home screen, or go to tutorial screen. And inside the tutorial screen, you can go to the details page, which gives you hints for grinding, adding water, and serving the coffee. Material app widget has the router factory constructor, and this is the easiest way of using Navigator 2 in our app. We create the router view model and mount the change notifier provider just above the material app. We inject the model to the view model, in this case out service and onboarding service. Then we subscribe to the authentication changes on init method and unsubscribe when the view model is disposed. The router view model has a state. It creates and manages the state with two information. One, the list of pages used by navigator widget, and the second, selected button navigation tab bar. This will be used when we are navigating to the orders screen, and in the initial state we show either the out screen or the home screen with or without the onboarding model route. When the router view model is created, we subscribe to the authentication state changes. For example, if the user is not logged in, we show the authentication screen. Otherwise, we show the home screen with or without the model. We have an example to master detail routing. When the tutorial destination is selected, the view, drawer in this case, calls the router view model. Here, we update the state and tutorial screen becomes visible. We do the same when details screen is selected. You can see how we update the state, declare the navigation stack according to the action. And then this is how you can show a model in a declarative way. First, we define a page, and this page creates the Vault model sheet route. When user closes the model with drag, barrier tab, or close button, we need to call the router view model that user closed this model sheet, and we need to sync the app state inside the router view model accordingly. We can use both imperative and declarative navigation patterns in the app together. And this example shows how to sync the imperative call with the navigation state. let's assume that the back button calls the navigator pop method imperatively. The navigator widget has this onPop page field which captures all the imperative calls in the app. And here we can inform the router view model that an imperative call has happened. We can also manage the selected bottom navigation bar with the router view model. For example, here, when the add water step is completed, we navigate to the order screen stating that we want the ready bottom navigation tab bar visible. And then handling the OS generated pops. The OS generated pops are initiated in the engine level, and in this case, the pop root method in the router delegate is called. In this method, we inform the router view model, and then inside the router view model, we navigate back to the order screen. We can also utilize a shortcut in the widget layer. We probably wouldn't want to close the app with the OS generated pops when the navigation drawer is open. In this case, we wrap the navigation drawer with the back button listener, and then this widget intercepts the pops, and the pop method in the router delegate will not be called. And that's it. Thanks for listening to me, and I hope you find this session useful. I know it is a lot of information, but you can watch this again and maybe decrease your frustration level.